Hello, everybody. Thanks for joining today. I'm Dennis. I'll be leading the second workshop for this session. So I've been working on Voiceflow for the past 2 years as the machine learning lead, and we've had a pretty interesting experience in adopting large language models. So we wanted to share some of that with you here today, go through some of our thought process, talk about a little bit about product management and choosing good use cases, but also on the technical side. So let's get started. So I'll introduce the business a little bit because I think it's very hard to separate use cases and technology adoption without knowing what you're building. A lot of people have been throwing ChatGPT or GPT-3 or large language models at any problem, but without understanding your customer and your use case, it's very hard to do that. So I want you to understand a little bit about where we're coming from and how we've adopted the technology. So Voiceflow is a platform for building conversational AI. So it's a collaborative canvas where you can create, deploy, and manage your conversational assistants. And we've been used by a number of large enterprises across different verticals. So banking, retail, automotive. We have a number of different use cases. You can find all of them on our website. But I think we're in 8 verticals right now, utilities, government, et cetera. So a lot of different companies using Voiceflow for conversational design, prototyping, and production deployments. So this is great, but the conversational AI space got shook when ChatGPT came out at the end of November. It was a big announcement, and everybody suddenly was using this new tool for interacting. And the existential question for our company was, do you need a way to design conversations in a human format when this seemingly magical model can do everything? And the answer was yes. We still do need manual tools. ChatGPT won't fix everything, but we did end up having a hack week to actually see how can we incorporate these new features and have a new perspective on our product. So here's a Slack announcement of a Slack channel that we formed, Hack Week 2022 in December. We did a 1-week hackathon, and then we shipped it in a week, had our winter break, and then announced it in the beginning of January. So other companies were starting to talk about, oh, we're using OpenAI, or we're starting to think about large language models. We said, let's not talk, let's launch. Let's see how people will actually use it. So for today's session, fairly packed agenda, but I want to go through some of the product side of things for the first 3 items, then start diving more into the technical aspect and some of the things that we've learned deploying and using large language models at Voiceflow. So the first thing I want to talk about is positioning, because this is something that's been crucial in people's minds recently. Everybody's been changing their company to use AI in some form. It's seen a huge amount of adoption. Everybody's talking about it. People are trying to tie themselves to sort of this zeitgeist. And the question as a company or as a product or as a team is, what's your position on using generative AI? So I think about it in 2 axes. What's your bet size and what's your company size? So bet size is how much are you investing in this? Is this a demo? Is this a feature? Or is this a full pivot of your company, right? And then when you're thinking about this, how big is your company? How much effort will it take to reposition your company as an AI company or reposition your product as such? So talk about something as an idea, as a scaling company, or as a large enterprise. So let's go through some examples. So in the YC cohort, so Y Combinator is a huge incubator. I think the news was out of the 300 companies in the cohort, 120 are building with generative AI. So these companies are in the seed stage. They're very early. They might not have a full product yet. A lot of them are just betting that they're going to be a generative AI company. And that's fairly easy to do because you just update your product, you update your website, you make an account with OpenAI or other large language model vendors, and there you go, you're an AI company. As you start moving further on to the right, as your company gets bigger, you have to take a more nuanced approach because companies who have customers, for example, like Voiceflow, we have 60 enterprise customers. If we were to completely reposition ourselves as just a generative AI company, that would have consequences. both on our customers and how they're using it, but also on our own sort of company and what we're building. We have a product to support. We have customers. We have real use cases. Now, the further to the right you get, typically you're going to see like a down to the right correlation here, where the bigger the company, the less of an aggressive position that you're going to take. But what's been interesting is that companies have been trying to market themselves as being more AI focused, even though it's not their bread and butter. Like we've seen almost every large company come out with a GPT or chatbot option. And the reality is that even though these companies are starting to position themselves as being AI first or like heavily dependent on AI, they actually make a lot of their money from other sources. So for example, Microsoft and Google had their big events about their making and incorporating products related to AI and generative AI, but in reality, they make most of their money in very boring ways, right? So Google, you have ads, you have YouTube, Microsoft, you have various products, gaming, enterprise software, etc. Right? So it's very interesting to actually see how much revenue companies are getting from these bets or potential future revenue versus how the public perceives them. So as a company or as an organization, it's something that you want to think about. A, what you're doing in practice, but B, what are you marketing? And what are the consequences of each? Because making this shift does have consequences. So once you've thought about this and said, okay, we're open to either building a demo or a product or completely pivoting our company, how do we find a good use case? And I would say these two are actually flipped. You should probably find a good use case first and then decide what to do next. But let's say that you've listened and thought about what's in the marketplace and you want to take action. So from our perspective, we found 3 criteria to a good use case. The first one is that you're optimizing a repetitive task or something that takes a lot of time. You want to save your users time. Whether it's a search or generating content, those are typically things we've seen in the market that are effective. And the reason you want to do this is because if it takes you longer to use a generative AI feature, let's say it's a use case of generating an intro statement for an email, right? By the time you open up ChatGPT and try to figure out if you're going to say hi or hey, right, it's not a very effective task. But if you're writing a long email or doing something similar like that, the trade-off becomes apparent. And what else we found is that human in the loop is super important. So somebody, a person, and optimally an expert is verifying, is this a good generative result? So rather than just having the algorithm, the model output something and go straight to production or straight to somebody else as a representation of the company, we want to have a person in between. And lastly, being cost effective. Making money is pretty important. But at the end of the day, the most important thing, apart from those 3 heuristics, is customer uptake, right? So are your customers excited about this product? Are you having paying customers? Is this something that people want to see? And this is something that we were, I wouldn't say pleasantly surprised by, but it was pleasant when we have customers who are some of the biggest companies in the world using our product and incorporating these features into it. So that was validation that what we built in the first version makes sense and is something that we want to use. So in this case, this was, we had a webinar with some of our customers, and they talked about their workflows and how things are being used. And here I'll show you a quick demo, just so we have an understanding of what we're building. So this is a quick walkthrough that our CEO is giving. Full screen. But basically, we're building a conversation here. Let's start off at the beginning. So this is the Voiceflow canvas. You're building a conversational experience in a collaborative way. We've turned on a feature called AI Assist. So you can see there, it's an opt-in feature. You don't have to use it if you don't want to. So what we're going to do is we're going to build a conversation using some of these features. So we're going to generate some variants for how the bot greets us. So that's going to be our first incorporation of the feature. So there we go. Connect to the API, generate some variants. That's great. And then we can go ahead and accept or decline those. Skipping ahead a little bit further, we're going to add some user actions, or we call them intents. We're going to generate examples that users are going to provide. So based on the name of the action that the user is going to take, which is purchase, we're going to generate some data. And this is where the human in the loop comes in. You can accept or decline those options. Okay, I think that's good. You get an understanding. You're building this conversation. I think we're going to run the prototype a little bit later. There we go. And then we're running the product right here using the generative features that we did before. All right, so that's what we built. Customers are using it. We're excited. Now, on the opposite side, we have a question of what hurts a use case. So what was interesting for the Google and the Microsoft demos was that we actually saw that the models made stuff up. They didn't give factual information. And this was curated by some of the biggest companies in the world with massive PR teams and marketing teams, yet it still slipped through the cracks, which is very interesting. So in the case of Google with Bard, it didn't correctly answer about the space telescope and sort of taking pictures of an exoplanet. And in the case of the Bing demo, it didn't correctly identify a financial metric. So even in the biggest demos in the world, the information that was generated wasn't necessarily true. So if you're going to be feeding this data directly to something that's audited or has exposure for a company, that is quite a large risk. So this is where the human in the loop aspect comes in and is so important. And the human in the loop aspect is about not just having anybody look at this information, because anybody looking at the information might say, yeah, that looks about right. But you need actual experts. So domain experts who can go through and accept or decline the recommendation or make a suggestion. So in this case, in Voiceflow, you can see we allow that very naturally with an acceptance and declining, with shortcuts and other methods to do so. So that's quite important to make sure that the end product you're building actually has good functionality and gets what you want done. Now, the third thing that I mentioned is cost, right? So these models are expensive. Running large language models is not for the faint of heart. That's why many people use APIs. So we need to make sure that your use case actually has some kind of ROI. Otherwise, you're just going to set money on fire. And that's what's been happening for a lot of machine learning projects in the past 5, 10, 20 years, is that companies have tried to do this. They've hired a big team. They've bought all this hardware or cloud compute, and then they get no results, right? So very important that you actually have some kind of ROI. I'm going to pause here. I haven't been looking at the chat. If there's any questions here. People are just connecting. Okay, I'll keep going. Feel free to ask questions in the chat. I'll make a couple other pauses. Okay, so for costs, the thing that we did is that we have a token allocation. So we provide 20,000 tokens for our free users, all the way up to 500,000 for our enterprise customers, and you can request more if you're interested. So this makes sure that people don't take advantage of our services, and we have a stop. So we've done some unit economics to say what's a good number of tokens to provide for each type of customer for them to be able to build what they want to build. So it's not overly restrictive, but not bankrupt us as well. So moving on into the next section, caching. So we do use some caching. The challenge with caching is that because we're a platform and support a number of use cases, everybody's a little bit different, right? So if we say we have 2 banks building conversational assistants, they might have similar phrasing for things, but if you're part of, let's say, TD, and you get a recommendation about RBC through a cache, right? That's not the best experience, right? So generally, we regenerate things per context, but if you go and reload something, there is some caching in there as well, once we've confirmed that this is something you want to use. So going back to UX and UI tricks, so this is something that's really important, is that if you incorporate your product, or you incorporate large language models into your product, you actually want people to use it. And I think the large reason that ChatGPT got adoption was not necessarily because of performance, was because it was fun to talk to. It was fun to use. You have this conversational experience that really captured people's imagination. So beyond just having a chat experience, we tried to incorporate these different UI UX features. So making it obvious how to use the feature, shortcuts, making it fun, making it natural. We talked about accept decline already, and then some other sort of standard programming aspects, so showing state and not letting people spam your APIs. So something that we were thinking about, and we're continuing to think about as well, because one of the aspects that we found is that UI and UX differentiates a lot of the adoption. If we think about generative images, Midjourney versus Lensa versus Stable Diffusion versus Dolly, what differentiated a lot of usage was just the UI, not necessarily the models behind them. Now, I talked about human in the loop, but making it more explicit about UX UI is that we have features that are both creation time and runtime. So what we mean by that is creation time is when you're making the assistant, you have a human in the loop who's going through and auditing what's actually being put into the assistant, versus runtime, which is we have a prompt block, we call it a generate block, where you can put a custom prompt and have it respond to your user. So creation time, much lower risk, human in the loop. Runtime, the large language model is basically only constrained by what the user puts there. So two different use cases. We prefer the creation time one just due to the risks we outlined with large language models, but we give customers the opportunity to use both. And what we found is that each customer uses this in different contexts. So enterprises for building their chatbots, like using it at creation time because they like the auditability and the control. But for prototyping and sort of experimenting, runtime has been very popular for things like prompt chaining and such. Great. Let's talk about data. So one of the interesting things is we wanted to understand how customers are actually using our product. So we added some user analytics, nothing new to web applications or mobile applications, but we wanted to understand how people are using it and actually making sure that we understand, are people happy with the results? So here are three different segment tracking endpoints that we used. So, or segment analytics items that we added. So one was that how many times do people use the generate feature? What kind of results do they get? And do they think it's an accept or decline or a modify? So we added several more, but this is just illustrating how we were thinking about it. How many times do users use it? What's the result? Are the results good, or do we have to change our prompts? And do people actually incorporate it into our product? And we end up streaming these segment events into our Google BigQuery, where we do further analytics on it and investigate it. Now, the other aspect is that we want to make sure that we tell the user whenever they're interacting with a large language model. So earlier in the demo video, we talked about how it's an opt-in, and we show you the terms of usage of when you're opting into this feature. So we want to make sure that it's quite clear when you're using the product and there's no surprises, right? No surprises if your data is being shared with a third party for the generation feature, no surprises of what the model might produce. We want to be very clear about that. And a lot of companies try to hide behind this because the risks of large language models are still fairly large, but we chose to be transparent with it. It's something we think that's important to the community and to our users. And even when you're interacting with a Voiceflow bot, you'll see that little AI feature on the right. So this is at runtime. You can tell immediately when something is generated by a large language model. There's no surprise if there's something that was written by a human or by our AI assist. So another aspect that we think is very important is that end users should know who generated the response. Okay, I'll pause here. I'll look at the questions.
Dennis, we can get to the questions after your presentation.
Okay, if we want to do it in that format, we can do that too. Okay. So deploying your own models. So I've been talking about API integrations, but let's step back and talk about what does it mean to deploy your own models. So here's another 2x2 matrix. And I think these are two important considerations. So the vertical axis is whether or not your model is self-hosted, and the left to right axis is whether it's self-trained. So whenever you're deploying a model, you have different options, right? You can use an API that is hosted by somebody else. I called it large language models as a service, which is kind of funny given that the Facebook model came out and it's kind of called llamas. So, but anyways, large language models as a service, which is what most companies have been adopting. That's not self-hosted. It's hosted by a third party, and it's already trained. You just use it out of the box. On the other side of the quadrant, you have a fully custom solution. You've trained or fine-tuned your own model. You host it yourself. And then in the middle, you have a combination here of various items. So this is an important consideration when you're thinking about your usage of these models at a technology level. You've defined your use case, maybe you build a prototype. How do you ship it into production? What's your deployment methodology? And here's a couple of examples, just what we've used or what we could use. So bottom left, we talked about large language models as a service, something like OpenAI. You can go a little bit further towards the top right and fine tune your models. It's fairly straightforward to use their API. You can go further up and start using a platform like SageMaker for hosting it, or various various other platforms. You could also host on Hugging Face, or rather host it on your own environment and use a Hugging Face model that's fully pre-trained. And then you go further on to the right. And you can see there in the top right, we've actually deployed our own custom trained and hosted applications. Not the largest language models, but we ended up building out our own framework to deal with a number of use cases. So it's a trade-off where you choose to train and host your models based on what you need to build. And the further away you get from the bottom left, the harder it becomes because it's not managed. But the more flexibility you get for things like managing your models, integrating with your workflow, privacy, data sovereignty, all these fun things that you need to consider. So here's an example of these things in action. So on the left here, we were experimenting with fine-tuning a model. You can see here that we just hit the API, we had some data, we trained it, and what happened was that we were put in a queue. So it actually took, what is this, an hour for our model to be put into training mode and another half hour to be trained. So because we're not the highest paying customer and not on the priority list, we don't have as much control here about fine-tuning our model. So that's a trade-off. If we needed to immediately train our model, we don't get that flexibility. But it was super easy to do. It was created, it's uploaded, we access it as an API. On the other side of things, on the right here, this is a training, real-time training log that we built for our own models. Not the largest models, but models in general. And you can see here, we send a request, and within 2 seconds, we're done training this model. So it's built for real-time training. It's custom built. We have a use case that's defined for it. And in this case, it serves our needs. But this was all built in-house. We do use a number of open source technologies, but it was a much higher investment than just calling an API. Now, this goes back to more of a philosophical or existential question of where should I spend my time in building products or models? So I think that it's important to talk about two different types of MVPs. The first one is your minimal viable product, and the second one is your minimal viable platform. So whenever you're building out a feature as a company, the most important thing is finding product market fit. Otherwise, your company dies, or your product dies, or your team gets disbanded. So you need to find something that's useful to your customers. But the trade-off is if you only work on prototyping and getting quick wins, you rack up a bunch of technical debt. So as a result, you have to alternate between building your product and building your platform, especially if you're at a smaller company or a smaller team. You can't just keep iterating on features if you're not going to invest on the platform side. And in our case, because we are a smaller team, our attention naturally alternated. We would build out a product or a set of models, and then we would figure out how to deploy them and optimize that process. It would kind of oscillate back and forth. But there's actually, I think, three aspects here. There's a product. So this is product market fit with your customer. There's the model that backs that product and how good it is with its accuracy. And then there's the platform that serves that model. Now, this is where a lot of companies fail, is that they oscillate between the top two, but then they don't build out their platform. And at the end, they ask, how do I do this thing called MLOps? Because it's so painful to iterate and deploy new models that it becomes much slower to iterate on the top two, the things that generate revenue or provide a good customer experience. So you need to make sure that you invest enough into all three of these areas in order to achieve success in your product. Back here. So for Voiceflow, we actually over-invested, I think, in the platform. I think if we were to go back when I first started, and the question was, do we build a whole ML real-time serving platform from scratch? If I was to go back and say, would I do it again? It's a maybe, right? We've seen success with it, but it was a large investment into something that even 2 years later is an ever-evolving field. So it's one of those things that investing in the platform is an unknown, because we built features that still aren't available in large machine learning platforms, but we did invest a lot of effort that we could have spent on the product or model side. So very large trade-off. I think this is an ever asked question of where do I spend my time? And the answer is it depends, right? It depends where the value is for your company, where are the challenges. But we did make I wouldn't call it a mistake, but we did make an overcommitment to building a very strong platform. And we've had benefits from it, but it was a huge investment. So going all the way back from that aside of large language models, custom deployments and such, this is generally how our architecture looks like for connecting to our integration. So we do use OpenAI to back our prompts and our large language model. And we've incorporated it into our existing architecture. So we have this middle service that we call ML Gateway that interfaces with our main product, which we call Creator. And this allows user requests and responses to go through. Now, we've added a couple more services or modules in here for prompt specifically. So prompt validation, rate limiting, and usage. As you saw there, we restrict the number of tokens that you use, which we typically don't do for other ML services. But we basically just added these 2 additional API calls for utterance generation. This was actually a model we did build in-house, so we just kind of hot swapped it. But what made it really easy is that we already had this modular architecture where we can just plop in OpenAI as a third-party service, add another couple API endpoints, and deploy it for our customers. So this is why that build took so little time, where we could build out 6 or 7 generative features in the span of a week, was because we did have a modular architecture where things fit in. If we didn't do this, if we hadn't developed any in-house ML expertise, this would have been much harder. We probably would have plopped it into some other backend service that didn't really make sense and tried to integrate it. It would have been more of a mess. So even though we're using a third-party service in this case, the fact that we had invested in ML infrastructure and ML research or applied research paid off, because it was an easy substitute. Now, talking about prompt engineering. So we incorporated with the OpenAI API. People might say, oh, that's easy, right? It's just an API. But we did run into some challenges, and I think many companies are running into some form of this. The first one was with prompt engineering and formatting. So we use JSON as our way of storing information and formatting it, because our prompts are fairly complex and have multiple parts to it. And we found that there were errors in actually parsing it. So anywhere between 1%, at some point it was 14% for certain prompts that we had to go in and fix. So we need to investigate and develop a system of how do we actually reduce this error rate. And the second part was dealing with challenging topics. So how do we actually make sure that whatever's being asked of our prompt or of our assistant, especially at runtime, doesn't generate bad advice or harmful content. So we had to figure out a framework to do both. So talking about prompting, one of the interesting things about GPT-3.5, we used DaVinci for the most part, was that sometimes it produced non-parsable JSON. So you can see here at the top, we would generate a certain phrase, but it wasn't proper JSON for two reasons. One, it had little code quotation marks. If you've ever written in markup or something else, you would see that those little angle quotes are quite devious. And you can see at the end of the JSON, there's actually a comma there that stopped it from being parsable. So we'd get these results back that are JSON-ish, but wouldn't necessarily be parsed by a native parser. So we need to clean that up a little bit, which was something that pops up when you start getting into higher volumes. At the beginning, when you're just doing a demo, you're like, oh, it looks great. But when you actually have to incorporate it into a system, it causes real problems. Malformed APIs are painful to deal with, and then standard programming, it doesn't happen often. Oh, yeah. Then we have that comma. We've been seeing that comma a decent amount. So we wrote a clause for it to deal with it. It's nothing complicated. It's some regex to find that comma in that use case. So at least the large language models are failing in a consistent way, which is nice. But sometimes they really do throw curveballs at you. Other examples here, we get back something that's JSON-ish, but there are quotes that are missing. So if we remember that use case of generating utterances or phrases, this needs to have quotation marks around both keys in the JSON format, and it didn't. So naturally, it would break. So the way we tested it is we did some manual testing when we initially developed the prompts. We looked at our existing files and existing use cases that customers could use. So we built out a test suite. But when we deployed it into production, we actually collected those errors from our data warehouse. So remember, we were storing those segment events in our data warehouse. And we then fed those errors into our test suite and tried out new prompts and compared the error rates and figured out, is this actually improving? Because you could run through a couple of experiments, but if you have 1,000 messages and you only test the first 5, the remaining ones might break, but the ones you looked at might not. So we actually built out this test suite that we run whenever we update the prompts and put them into our prompt store in order to make sure that things actually work. So what that looks like is, here's an example of processing some of this code. We have some prompts here. We have some Python that we'd run, and then we would print out and document the errors. So in this case, you could see various JSON errors, double quotes, commas, etc., that we would see. And then we would adjust the prompt and make sure that it would actually work. So this goes back to a testing methodology. You might say this is very basic, or there are better ways to do this, and we agree. We're still early in this process, but we wanted to make sure that we did have some kind of testing framework to deal with it. Now the question might be, why don't you just fine-tune the model to get the format you want? So fine-tuning is definitely a great approach. We did actually try this for a number of use cases, and for formatting, the results were great. Apart from just doing few-shot learning and chain of thought reasoning, this is a good way to deal with format issues. The question was, what kind of data do we want to get back in terms of accuracy? So one of the experiments that we ran is that we built actually a QA bot for Voiceflow that's incorporated into the product right now, where it would scan our knowledge base and you could ask it questions. And we would still need it to be formatted in a certain way so it could be parsed by our front end or by our other services. So when we used a base DaVinci, we would get answers that were quite good. The problem was that they were slow and sometimes malformatted. I think in this example on the left, you can see that there are 2 answers that don't follow the JSON exactly. Now on the right here, you can see that the responses are much faster and much better formatted, but there are things that are made up or improperly communicated. For example, we asked a question of what are the 5 principles of NLU design, and something from an article we wrote. And DaVinci gave a good answer. Fine-tune Curry did not. So in this case, we were trying to fine-tune and say, if we have a custom model with custom formatting, can we improve the speed of what's going on? And how we fine-tuned it, we actually used an interesting methodology. We used our large language model to generate questions and answers based on our documents. So in this case, we had 3. So as it went through each document, we would have questions that are generated. It would then generate the answers, and then we'd use people to make sure that it was the right answer. And it was an interesting way to sort of chain our different prompts together and our different tasks, and use these large language models to automate a large portion of it. So just wanted to share that in terms of how we actually went through. And we didn't directly inject these answers in our fine-tuning format. As you saw there, we have a slightly different one. We have an answer, a document, and a URL link. We then formatted it accordingly to our fine-tuning needs. You might ask the question, ChatGPT Turbo just came out. Why didn't we use that? Well, we did an experiment. And the results were same-ish as DaVinci. I think that's what the research is showing. DaVinci is a little bit better than ChatGPT Turbo for some tasks. So we ran it again on our QA bot. You can see here there's a comparison. We asked a question like, why is the sky blue? And we measured what is the time and answer for each one. And the results were same-ish. Again, we didn't run through all the possible use cases, but it was 10x cheaper to actually implement it. So depending on your use case, ChatGPT Turbo is a great investment. But in other use cases, you might want to use your standard model, especially since you can fine-tune it rather than not being able to fine-tune ChatGPT. Okay, another set of issues we ran into. So beyond just prompts, OpenAI times out. That's because the company is growing. It's gotten a lot of attention, but it's not a reliable API to hit. And I say that in a positive way, because when you are going through intense product market fit, things start to break. So the team there, as they have said, is on fire trying to deal with all of this. But as a consumer of that API, we need to figure out how do we actually use that. So in the case of a product, it's actually okay at creation time, because if you're going through and creating your chatbot and it says, oh, sorry, it didn't work, you can just hit retry. It's not the end of the world, but it's not the best experience. At runtime, however, if you're chatting with a bot and it says, oh, something went wrong as a customer, then it becomes a little bit harder. And we've actually have 2 runtime features. We have our custom generate step that is a directly implemented one, but we also have a custom API step. And what we found was that when OpenAI was taking so long, either with a 429 error or just taking more than 10 seconds, it would actually break our custom API step because the timeout was 10 seconds. So then we went ahead and actually increased it to 30 to help some of our customers in our internal uses for connecting to longer running APIs. So we had parts of the product break in interesting ways because of this shift. So something to consider as well. Now, the other thing is that you could just retry. You could put in retry logic for 429s when the server is too busy, but your customer doesn't care. They just say, oh, it didn't work. So they'll refresh and click it again. They're not going to wait and be like, oh, how lovely. They're retrying this logic. I'm going to patiently wait. No, they're going to hit the retry button and spam it. So the 429 errors didn't actually have too much impact for us. Now, going back to the latency, you can see here, this is a proof of concept that we were working on for a QA system. And what this is showing is the P50s, P90s, and P99s. So those means, that means how much time does it take in the 50th, 90th, and 99th percentile to return an OpenAI call. And you can see here, a lot of these are going up into the minute range. So that was too long for a user and too long for our API step. So we made sure to monitor and track that. You can see that these requests are fairly infrequent. I posted them for a staging environment that we have, but we ran into these issues and things that we had to monitor and things that we weren't expecting to run into. So we wanted to make sure that we were actually monitoring these things to understand what corner cases could we run into before we ship them to our customers. Now, the bigger question is, what happens if OpenAI goes down? There was actually an outage a couple of weeks ago, and a lot of products just stopped working. So if we go back to our matrix of how much do you bet on this product, if OpenAI goes down and you're a wrapper for it and it's a key part of your product, well, your product went down. And in our case, because it's a feature within Voiceflow, we weren't as affected as much. Now, how does this connect to reliability and integrations? So as a company, you have a choice when you're dealing with your downstream dependencies, whether they're APIs or open source libraries. If you look up the uptime of OpenAI and you see that it has a 98.58 reliability rate in January, that's thankfully been improving, you can make the decision of, do I want to use that API? Or do I want to have a multi-LLM strategy where I'm using multiple APIs and calling them? So am I using Anthropic, Cohere, or Hugging Face as some examples? So you can make that business decision to say, how much uptime do I need? And this is something that you typically look at in an operational capacity. And if we look at Hugging Face's and Cohere's uptime, it's been quite a bit more reliable. We're seeing 3 nines, 4 nines of uptime on these models, which is quite a bit better than OpenAI. Then it raises another question of how important is model accuracy versus model uptime, right? You get into these trade-offs of the perception right now is that OpenAI has the best models, it's the biggest brand name. So are you going to use another provider because it provides more reliability for your product? And that's something that you have to consider, because that extra 1% accuracy for some products means everything, but for other products doesn't matter too much. And this gets into a whole infrastructure, reliability, and SRE discussion, right? So AWS has this great graphic of thinking about dealing with downtime and how much you're willing to invest into it. So in our case, we just have one API that we're integrated with because we're okay with the SLAs or SLOs that we're getting. But if we were a much more mission critical application, let's say we were dealing with healthcare data or something else, and we needed much higher uptime, we would invest a lot more money into it. And this is kind of the trade-off you have to make as a business, is that are you going to run things with the lower reliability, simpler system and lower costs, or are you going to get into these much more complicated architectures and fallback options? So large language models are still covered by this whole paradigm of measuring uptime, reliability, and ability to recover. And again, it goes back to the question of, are you running this at creation time or runtime? So it goes back to that question of, where do you serve the model for your user? Okay, talked about deploying your models already. Again, goes back to that question, can you have higher uptime than OpenAI or third-party providers? The answer is likely no, unless you're specialized, but that's a decision that you can make. Okay, I'm running low on time, but there are lots of cool new models coming out. Flan T5 was open sourced. We're getting better at running large language model inference. This paper on 8-bit inference came out this 2022, earlier in the year. We're getting Flan UL2 that just came out and was open sourced. We got Llama that was leaked and the paper came out. So the space is moving so quickly that at some point you might want to deploy your own models because it becomes so much easier and you have so much more control. It's moving at a very fast speed. This talk might be completely different in a month, right, given the speed of progress. And here's a graph of our model failing in production. We had a 1-hour downtime for one of our models, because that's what you deal with when you run a product. So there is a trade-off with using your own models versus other people's models. Depends how much you want to manage.